Good evening. So, welcome to the fourth lecture for complex numbers and quadratic equations from the class 11 mathematics. So, since we were dealing with complex numbers, we started with understanding how basic algebraic operations like finding the sum or difference or product or divisibility of complex numbers are done. And so we also solved a few examples to understand how these operations vary when we are trying to solve them or apply them on complex numbers. So now we will go on to understanding the different the application of power. Okay, so power to I, and we will also try to see how the square root of negative real numbers are found out in today's class. So, since we have already seen, like we started with the basic assumption or how actually the imaginary unit I was defined is that I is equals to square root of -1. Therefore, I square is equals to -1. Okay, so this is something that we already know. Okay, so this is the description of I and the power of I. Now, if we want to find different powers of this, okay, so if you take I cube, for instance, you can first you can bifurcate this. Okay, in we already know I square is -1, so it is easy for us to remember this. Okay, so anytime you find or you are asked to find the power of I, and this power can be any number. It can be a positive number or positive integer, or it can be a negative integer also. So first we will see how the positive integers, how you can simplify this and try to find the value of it. So I cube, you can write it in terms of I square into I. Okay, so you can bifurcate this or simplify this in this form. Now we already know that I square is equals to -1. So we can multiply -1 with I. Okay, and the value that you get is I. Now, similarly, if we take I raised to 4, okay, so I raised to 4, again, you can either, keep kind of you bifurcate it, okay, as a product itself, or you can write it as the square of I square 2. Okay, so both ways you can simplify it to try to find out when you have 4 as the power. So in this case, again, you will have -1 multiplied by -1, and that would be equal to 1. And if you consider, or if you have, taken it in this form, you can write it as -1 square. So this again is the same thing. So what you are left with is 1. Okay. And now if we take different kind of, powers, like if you take I raised to 5, you can again either take it in this square form, or you can take it in the product form. So if you want to take it in the square form, okay, so since we know that square of I square is 1, okay, so this is also easy to remember, or remember the simplified expression of it. So you can write it in terms of I square multiplied by I. So what you're left with is I. Okay, and then if you take I raised to 6, so again you can write it in the square form itself, or you can write it in the product form. Then if you want to write it, in the product form, let's see. Okay, so you can write it thrice I square into I square into I square. Okay, so over here, each of them you can, if you remember, I square is equals to -1. Okay, so you can write -1 multiplied by -1. That again gives you -1. Okay, so this is how we can find the find the power of I. Okay, the power relating to any positive integer over. Okay, so I of k can be found. Okay, in this sense, where k is for the example over here, we are taking this as positive integer. Okay. Now, obviously, every time when you are given, I raised to some integer, you might have to either, do this entire, simplification or expansion, and it becomes tedious, and there has to be some easier general form. Okay, so let's try to see if you have even numbers. Okay, if you take any even number, how would it vary? So over here we see that if you have taken 2, okay, if k is equals to 2, your I raised to k would, range from, say, it will be -1. If your k is equals to 4, your I raised to k would be 1. But if your k is equals to 6, then again you are getting as I of say 6, you will get as -1. Okay, so then there is no particular pattern being followed. If you just take as if you try to write if k is only even. Okay, so there is no general pattern followed. So if you say in that manner, so if you for any integer k, okay, okay, for any integer k, okay. So if we try to write it in the general form of where we try to see for every even power, will we get the same result or not? So if we take 2k, okay, suppose this is your general form. So, and we will take k ranging, from say is equals to 1, 2, 3. Okay, so let's try for these. So 1 square again is -1. So 2 into 2 I raised to 4, as we just saw before, is 1 again. Okay, and I raised to 6, 2 into 3 was also -1. Now let's see if I 2k plus 1. Okay, if there is a general pattern being followed by this, again we will take k as 1, 2, 3. So in that case, if your first k is 1, so this is 2 plus 1, so I cube is going to be I cube is going to be I think it was minus I. Yes, minus I. Then if you take 2, so 4 plus 1, so again I raised to 5, we have already seen is I. And then if you take 3, so 3, 3 into 2, 6, 6 plus 1, 7. So if you take 7 over here, okay, so if you generally expand it, so what you will get is, say, I square of cube, okay, and multiplied by I. If you just, simplify it, then what you get is actually -1 multiplied by I, so it is -I. Okay, so again, you can see that there is no pattern being followed. Okay. If you just follow in this general form or in this general form. Hence, what is the general form that is actually followed is I for k. Okay. So if we take it as 4, okay, so whichever power is actually a multiple of 4, it will always give the unit, okay, 1 as the answer. So let's validate and see how it can happen if you take k is equal to 1, 2, or 3. Okay, so I is equals to 4, we know already is 1. I 4 into 2, 8. Okay, so again, you simplify this. I raised to 4, since we already know uh, this expression or this relation. Okay, so 4, 4. So this is again 1. Similarly, if you take 3, sorry, if you take 3, okay, so that is 12. So you have I4 into I4 into I4. Again, you are left with 1. Okay, so over here you can see for any integer k, okay, you multiply it with 4, you get a uniform relation. Okay, now if you consider for say odd numbers, okay, with respect to your 4k only. Okay, so k plus 1 if you take. Let's see if a general relation is again followed. If you take k is equals to 1, 2, and 3. Okay, so over here, you have 4 plus 1, 5. Okay, we've already seen that is I. Okay, now over here, 8 plus 1, 9. I raised to 9. Okay, now if you take that as your I8 multiplied by I, over here we've already seen that I raised to 8 is 1, since 8 is a multiple of 4. So then again this remains I. Similarly, if you take this as 3, k as 3, then 4 into 3, 12, plus 1, 13. So I raised to 13. You can write that as I raised to 12 multiplied by I, and that again becomes I. So again, you can see for every, therefore, we can, generally write that. I think it's better if I write it in a different color. Yeah. So I for k plus 1 is always going to be I. Okay, I for k is always going to be 1. Okay, so these relations are what you need to remember when you're solving. Okay, now let's see if we take when we have seen that you get 1, you get I, you get minus I and minus 1. Okay, so any kind of power of I, if you put any integer as the power, you have to get uh, uh, one of these as results only. Okay, so either you'll get 1 for I, or minus 1, or minus I. Okay, so we have already seen what is the general form that needs to be, that gives you 1. And we also saw the general form of power of I, which gives you I. Let's see a different one. Okay, so if you take 4k plus 2. Okay, again taking, k is equals to 1, 2, and 3. So what you get is I is equals to 4 plus 2, that is 6. Okay, is equals to I6. We have already seen that gives you minus 1. Okay, now if you take 2 into 4, 8 plus 2, so that is 10. Okay, now if you remember, you can write it this as 8 I raised to 8 I square. Okay, I raised to 8 is 1, and I square is equals to minus 1. So this again becomes minus 1. And similarly, 3 into 4, 12, 5 plus 2, 14. So I raised to 14. Again, you can write I 12, since we know 12 is 12 is a multiple of 4. Okay, and then again I square outside. Okay, then again what you're left with is minus 1. So again, to write it in the general form, we can mention mention in the sense that I 4k plus 2 is always going to be equal to minus 1. Okay, now let's see when we will get minus I. Okay, what is the general form of getting minus I when we want to find the power of I? Okay, so this is plus 3. K again we'll consider going from 1, 2, and 3. Okay, so first one is 4 plus 3, 7. Okay, so we have already solved it over here. So that is minus I. Okay, then I 8 plus 3 is 11. Okay, then again you try to get simplify this to get 1I to the raised to the power to a multiple of 4. Okay, so the closest one that we have is I raised to 8, I cube. Okay, and then you can express this will become 1. And if you consider I square dot I, and then again this is minus I. Okay, if we simplify I cube also, because this is 1, okay, this is equals to 1. And then you get this. Similarly, if you take 12 plus 3, 15, I 15 will also be equals to minus 1. So you can again write this in the general form as I 4k plus 3 is equals to minus I. Okay, so is minus I. Okay, so then this is your general form. So this is, when we are trying to consider, the positive integers. Okay, positive integers as powers. Okay, let's solve a question related to this. Okay, so just an example. So suppose the question we have. Okay, so we have to find the answer to 1 plus I raised to 6. Okay, so this is your expression given. You have to find what this is. So to find the answer, you try to get these into the easiest form of powers. Okay, so you can solve it easily. So the easiest identity that we know is a plus b whole square, and then you expand it, get a square plus 2ab plus b square. Okay, so this is one of the easiest identities that we know. So let's try to get that in this form. Okay, so you can make this into 1 plus I raised to 4 multiplied by 1 plus I squared. Okay, now this part you can again simplify as 1 plus I squared. Okay, and you expand this paragraph. Okay, so 1 plus 2I plus I squared. Okay, let's keep it at that. You expand this bracket also, and you can keep it. So this is again 1 plus 2I plus I squared. The whole thing is squared. Okay. And this, since we know I square is equals to minus 1, you can just, substitute it for that. Okay. So if this is minus 1, then 1 and 1 minus 1 will get cancelled out. What are left with is 2I. Okay. Now, over similarly, if you substitute for I squared, what you are left with is 2I squared 2I. Okay. Now over here, 2 squared is 4. And again, you have I squared 2I. Then I squared again, since we know that I squared is equals to -1, so this becomes -4. -4 into 2, 8. Okay, so this is minus 8I. Okay, so this is your answer. So this is how you can solve when when you have to solve for identities also. Now, if you similarly as we had seen different these general forms, if you are given a question, okay, I think that's the page. Okay, so let's try to see if you are given say I-38. Okay, so this is a different question. So let's try to expand this or simplify this in a way that one part of this I we can write it in the power, which would be a multiple of 4. Okay, so the closest one that we have is say 36. Okay, so you can write this as I 36 multiplied by I squared. Okay, now since 36 is a multiple of 4, okay, so we know that this will, if you simplify it, in the full extent also, what you will be getting is, since we know that I4K is equals to 1. Okay, so this is something that we know. And we also know that I squared is equals to -1. So what you are left with is 1 into -1, and then you have -1. Okay, so this is the answer for this. Now, if you suppose, you have another, say 19. Okay, so the closest multiple of 4 that we have is 16. So you have I16, I cube. Okay, you can expand this further since it's easier to remember that I square is equal to -1. So you have I square, I. Okay, so this is 1 multiplied by -1 multiplied by I. So you have minus I. Okay, so this is how you can solve if you are given different powers. Now let's see. So what we have seen all the way till here is that when we have the power as positive integers, okay, what would happen if you have negative integers? Okay, if I raised to k is what if k is negative? Okay, so suppose for the most basic example, you have -1. Okay, you can write this in the form of 1 upon I. Okay, now if you remember, this is kind of like an inverse of I. Okay, to understand or to find out the example, the solution for this, you can multiply and divide by I itself. Okay, so it is easier for you to get the denominator in a sort of a positive, positive power of I. Okay, so what you get is I upon I square. Now we already know, since I square is equals to -1, so what you get is I into, uh, so what you are remaining is I and -1. Okay, I upon -1. So this gives you minus I. Okay, now if you have I is equals to -2, so 1 upon I squared. Now we already know that I squared is equals to -1. Okay, what you are remaining with is -1. Now let's say if we take I raised to -3. Okay, so 1 upon I cube, and then 1 upon, you simplify this in the form where we know the general expression. Okay, so I square multiplied by I. So what is remaining is 1 upon minus I, since this is -1. And if you what the final answer that you get is I. Okay, when you get I in the numerator form. Then again, if you have -4, okay, -4, this is 1 upon I raised to 4. Now I raised to 4 we know is equals to 1. Okay, so this is 1. So this again kind of follows a similar rule that we saw when we were doing the inverse kind of a thing. So for example, if now taking k as negative, okay. So if you try to see if the similar general forms that we had, tried to see before, like 4k plus 1, if you can validate that with negative integers also, okay, taking k as your negative. So first we do with 4k, okay, and k we will start with -1, -2, -3, okay. So what we get with I raised to -4, we have already seen over here, okay. We have already seen over here. So I will just write it in this form so it becomes easy. Okay, then again, if you have I raised to -8, it's similar 1 upon, say you have already simplified this. Okay, then 1 upon 1, it will be 1. Okay, similarly, it will be the same for 3. And then let's try 4k plus 1. So k is equals to -1, -2, -3. So -4 plus 1. So you get -3. We have already seen I raised to -3 is I. Okay. And then if you have -8 plus 1, so -7. So let's try to solve this. So 1 upon I7 is equals to 1 upon, simplify this in the form of this, general form that we know the answer, is easier. So I4, IQ, okay. So now this is 1 and we have seen, okay, IQ, you will be left with -I, then that is also equal to 1. Okay, so again, we can see that the general forms, that we had written before, okay. For example, I4k is equals to 1, I4k plus 1 is equals to I, that we have seen here. And similarly, if you try to solve, for negative k and you substitute in these general forms over here, these are the general form, the validation does remain even in when we are taking k as negative. Okay. 4k plus 3 is equals to -I. Okay. So all of these are valid even when k is a negative integer. Okay. So let's try to solve a question, using similarly what we had done before. Say, um, okay. So suppose the question that you have, okay, is you have to find plus 3i, say -1 itself. Okay, so if you remember when we were trying to do multiplication and division, there was a term that we had introduced that was multiplicative inverse. Okay, so this is a kind of a similar kind of situation. So you can write this as 1 plus 3i. Okay, so if you remember that any multiplicative inverse can be written in the form a upon a square plus b square plus I minus b upon a square plus b square. Okay, so if you write it in, if you try to, write it in this form, what you get is A is 1 and B is 3. Okay, so you have 1 upon 1 square plus 3 square plus I minus B, so minus 3 upon 1 square plus 3 square. Okay, so when you write it in the final form, you get this as 1 minus 3I upon 10. So this is equals to 1 upon 10 minus 3 by 10 I. Okay, so this is how you can find. Now you can try to find if with minus 2 how you can get. Then you will have to expand and try to reduce it. Okay, so let's now go to understand square roots of negative real numbers. Okay, so we know very easily, square root of 4 is equal to 2, square root of 36 is equal to 6. Okay, so we know these things. But now let's try to, because when we had started understanding complex numbers, the first ever rule that we had, presented is that I is equal to square root of 1. Okay, so now if you try to understand I square, okay, is equals to minus 1, we know this. So, but it is also true that if you have minus I square, okay, so if you try to, get, because then again, if you take minus I, the similar answer is received. Okay, so therefore you can say that square root of minus 1 can be plus minus I. Okay, if this holds true. But when we are considering minus 1, okay, we keep it in the form of I alone. Okay, so we don't consider minus I. So we, since, previously we had also solved for the equation, say x square plus 1 is equals to 0. Okay, so where x square is equals to minus 1, therefore x, would be x would be root of minus 1, and in if you take this as the correlation, okay, then therefore x is equals to I and minus I. Okay, now if we consider another different roots, say over we take 3. Okay, so if you have sorry, we are trying to find the negative one. Yeah. So, suppose you are given minus 3, okay, and you have to find square root of minus 3. Okay, so this is, this is difficult to find. That is why we had introduced complex numbers for, for that matter. Now, if you just take out the minus 1 from here, okay, so since square root of, minus 1 is equals to I, and I squared is equals to minus 1, just take out the minus 1 out from here. So what you are left with is 3I squared. Okay, if you take the minus 1 outside. Now, if you remember, okay, so minus root 3I squared. So this way you can find the cube root of the positive number. Okay, you convert this into the your positive number. Okay, so now if you try to square it, okay, actually sorry, we are supposed to consider with the I think it's giving around. Okay, so suppose you are given the number, say root 3I. Okay, so this is your Z complex number. Okay, so you want to find this. So if you try to, square, you find, square both the parts. So you have root 3 square and I square. Okay, and what you are remaining with is minus 1 equals to minus 3. Okay, so we can find, minus 3. Okay, so therefore you can say that square root of minus 3 is equals to 3. Okay, according to, sorry. Mm, Okay, so over here we had taken, okay, 3 under the root, okay, and we got minus 3. Okay, so this can be there. Okay, so therefore square root, we are trying to find the square root of minus 3. So one of the roots that we can see is root of 3. Okay, and now if we take z is equals to minus of root 3i. Okay, suppose you introduce a negative sign in front of the root 3. So z square would then be minus root 3i squared. Okay, now already you have then minus root 3 and you take out the I square outside. Okay, this also remains squared. Okay, so we already, over here again, what we find is, okay, this will remain your minus, okay, you again get minus 3. Okay, so but over here we saw that minus root 3 is also a square root of minus 3. Okay, so minus root 3. So when we are, trying to find, therefore, if we write it in the general expression that we have, so minus uh, square root of minus 3 will represent both, kind of root 3. Over here we are, trying to see that both root 3 and the negative root 3. Okay, if you get. So that again, because if you actually expand this, okay, so if you expand this, what you will actually remain with 3 and, a negative sign. I will expand this so it's easier to understand. Okay, so when you, multiply minus root 3 into minus root 3, the negative sign, turns positive, and what you are remaining is 3 and minus 1. So again, it is minus 3. Okay, so will be and minus root 3. Okay, but we consider only the positive root that we have. Okay, but we consider only root 3i. Okay, so this is what we and like what we consider. We consider root 3i as the square root of the negative 3. Okay, so this is how you can find the square root of a negative real number. Okay, so let's try to see some properties that need to be validated. So we saw that uh, square root of minus a will be a root of minus 1. Okay, and that is equals to root of ai. Okay, so this is the general expression that we are getting. Okay, I'll just box it up in a red one so we remember this. Okay, so for example, if you find try to find the uh, square of minus 9. Okay, so you can take the 9 aside and minus 1. Okay, and that will become 3i. Okay, now again, there would, since we know that, square root of 9 can be both plus and minus, 3. So you can write this as plus minus 3i. Okay, so I is always introduced when we have to find the negative of the the square root of a kind of negative real number. Okay, so now let's see if you get two different real numbers. Okay, you try to find two different real numbers. For example, you have A into A B. Okay, over here you can consider this as this correlated with this form. Okay, so that would be equal to the both the real numbers come under the square root then. Okay, so this is kind of the inverse representation of what we have done over here. Okay, but this is valid when your A is also positive and B is also positive. It is also valid when your A is positive but B is negative. Okay, or A is negative but B is positive. Okay, so what happens if both the numbers are negative? Okay, so for example, let's take the most fundamental form that we have. Okay, we know that I squared is equals to minus 1. Okay, so I squared, you can write it as I into I. So you have minus 1 into minus 1. Okay, so if you, follow this form over here, that you take both of the, numbers under one square root, then what you get is minus 1 into minus 1. But now this minus 1 into minus 1 changes into the positive, and then what you get is 1. So over here, this is, then we can say that if we solve it in this manner, okay, then I square is not equal to minus 1. So this is contradictory. Okay, so this is a contradiction that we face. Therefore, we say, okay, so therefore, root of A into root of B is equals to square root AB is, sorry, not equal to square root of AB if A is a negative real number and also B is a negative real number. Okay, so this is something we have to remember. Okay, also another aspect that we have, if A or B is 0, okay, so what happens is A square root of A into square root of B is equals to, when if any of them are 0, what you are remaining, what you get is a 0. Okay, so this is another statement that you will have to remember when you are solving. Okay, so now we will see some examples for this, kind of square root. Okay, so if you have, okay, so question, we know cube root of unity is 1 omega square. Okay, then what is x minus 1 cube minus 8? Okay, so what is x in? Okay, so we know that cube root of 1 is equals to 1 omega and omega square. Okay, so over here omega and omega square are actually complex numbers. Okay, we are not going into the proof of this for now, so I'm skipping the proof part of it. Okay, so if we take this, so x minus 1 cube root is -8. Okay. So then if you, take the cube root on both sides, you have minus into cube root of -8. Now over here, you can see the difference that you can actually find the cube root of a negative real number. How we could not find the square of a negative real number over here, we can get. So this is -2. Okay, x is equals to -1. And this is equals to -2. Okay, -2. Now, since we are actually considering this as actually also cube root of 1. Okay, so this you can write it in terms of -8 multiplied by 1. Okay, because we have to satisfy this assumption that is given over here. So this is -2. Okay, so if you multiply with the each of the roots, so you have x minus 1 -2, also -2 omega, and also -2 omega squared. Okay, so therefore x is going to be, if you take -1 on this side, you have -1 or is equals to 1. So this is +1 -2 omega, and over here you have -2 omega squared. Okay, so this is what we get. Over here, this is the difference that we can see in a square root of a negative real number and the cube root of a negative real number. Okay, so we can find it in this manner also. Now let's see some examples of what we had done when we were doing more examples of algebraic expressions. So one example we can take as solve the expression if it is given in this manner. Okay, so if this is a question, so you have 1 plus I multiplied by 1 plus I. You multiply the numerator and the denominator with the how you normally solve for fraction. So 1 minus I and 1 minus I, and this becomes 1 minus I, 1 plus I. Okay, so again, we are trying to get it in the power form over here. So this is 1 minus I squared. Okay, so you expand this 1 plus 2I plus I squared minus 1. Okay, so this is minus 2I plus I squared. And this is 1 minus I squared. Now, since we already know that I squared is equals to -1, okay, so you can write this as 2I, because I squared becomes -1, then -1 and 1 gets cancelled out. This remains as 2I. And similarly over here, this becomes -1, so -1 and 1 gets cancelled. In brackets, you have 2I. And I square over here becomes -1, so -1 and minus, you will get 1 plus 1. Okay, so over here, this becomes the addition, so you have 4I upon 2. So what you are left with is 2I. Okay, so this is your answer. So over here, we saw a combination of, the different operators, or how the powers actually help us in getting or simplifying different examples. Okay, so for today we will finish off over here. And in the next class, we will do the different identities. Okay, so identities as in the algebraic equations that we have, like a plus b the whole square and a minus b the whole square. And or we will also see how the cubes of two complex numbers added together or subtracted together. We will try to see how we can solve those, and we will try to prove these identities also, so we can see if they are being valid or they are not being valid, and how exactly we can solve some questions based on those. So thank you, and hope to see you in the next class.